morning all. Hope everybody doing good. In our last video, we discussed about the magnetic circuits with respect to the dot convention and we solved the different problems. Today, we are going to discuss about the concept of parallelly connected magnetic circuits. That is, in the case of a previous video, we seen the series aiding and the series opposing circuits. That is, electrical connections. In the electrical connections, we discussed these two. Today, we are going to discuss about the electrical, physically connected, but the current is in opposite direction. That is parallel. The current is dividing. Okay. Hope this is my presentation for you to understand the concept of parallel magnetic circuits. In the parallel magnetic circuits, I just shown an example having the two coils which are connected in parallel. Okay. In the both cases, the dot is present in the either current entering side or current in the both the coils current leaving side. Okay. Understood? The dot may present at the in the both the coils either current entering side or current leaving side. Then only we are saying this is a parallel additive or parallel cumulative. We can use these two terms, parallel additive and parallel cumulative circuits. Okay. So as we know that the L1 is the coefficient of self-inductance of coil 1 and L2 is the coefficient of self-inductance of coil 2 and M is the mutual inductance of the two coils, that is M12 and M21 we are calling as a M only. Okay. So the self-induced EMF in the coil 1 is minus L1 dI1 by dt, as we know that. Okay. From the Faraday's second law, V equals to L dI by dt. So from coil 1 we are writing L1 dI1 by dt and second coil 2 L2 dI2 by dt. Minus is the term for the Lenz law. Okay, because the generation of any EMF which opposes the cause for its generation, so that we are placing the negative sign over here. Okay. Similarly, the mutual inductance, how we are going to write the mutual inductance of the coil 1 is M di2 by dt. Okay, M di2 by dt. The mutual inductance of coil 2 is M di1 by dt. Okay, understood? I will tell you again. The mutual inductance of coil 1 is M di2 by dt. Mutual inductance of coil 2 is M di1 by dt. Understood? The symbol of for an additive polarity, because the current entering at both the dotted terminals, the sign of mutual inductance is follows the self-inductance. We are considering negative sign. So the mutual inductance of coil 2 and coil 1 is, I am writing as such, minus M di2 by dt minus M di1 by dt. Okay. So that the total induced EMF in coil 1 is the self-inductance of coil 1 and the mutual inductance of coil 2. Okay, that is minus L1 di1 by dt minus M di2 by dt. Okay, and the total induced EMF in coil 2 is minus L2 di2 by dt minus M di1 by dt. Okay, in a parallel circuit, the total voltage across both the coils must be same. That is, I am equating these two. Okay, and I am taking the L2 terms in left hand side and I1 I2 terms I am considering in the left hand side, I1 terms I am considering in the right hand side. So I am sending these two. I am taking common of di2 by dt. So I get L2 minus M. If I taking common L1 di1 by dt, I will get L1 minus M. Okay. So di1 by dt in terms of di2 by dt I am writing. Okay. So if I send this term, this is L1 minus M in this side, we will get di1 by dt as L2 minus M by L1 minus M into di2 by dt. Okay. So this is, I am representing di1 by dt in terms of di2 by dt. In parallel, we know that the total current I is the sum of I1 plus I2. Similarly, di by dt equals to di1 by dt plus di2 by dt. Okay. As we know that di1 by dt in terms of di2 by dt, I am placing over here, and di2 by dt. I am taking common of di2 by dt, so that I will get this value. Okay. If I take the LCM, this is the value. Okay. So the value of di by dt in terms of di2 by dt, I am noting down as a equation 1. Okay. As we know that the total induced EMF across any parallel combination B equals to the total, I am considering it total L equivalent into di by dt. Okay. So V equals to L di by dt. So I am considering the total inductance of the parallel circuit, V equals to L equivalent dI by dt. Okay, L equivalent dIT by dt equals to the self inductance of coil 1 and the mutual inductance of coil 2. Okay, why? Because in parallel voltage is same. I can write another equation also, that is minus L2 di2 by dt minus M di1 by dt. Both the things conveys the same. Why? Because in parallel voltage is same. Okay, so I'm considering this one L equivalent di dy. I mean, cancelling the all minus terms, so that I will get L equivalent di by dt equals to L1 di1 by dt plus M di2 by dt. As we know that, okay, sorry, I'm sending the L equivalent in this side, so that 1 by L equivalent equals to this value. Okay, next, substituting the di1 by dt value in equation, we know that di1 by dt value. So as we derived equation 0, that is L2 minus M by L1 minus M into di2 by dt. So I am substituting in the place of di1 by dt, so that this is with the value. Okay, so the value is in terms of di2 by dt. So I'm taking the di2 by dt as a common factor, so that I will get the di1 by dt in terms of di2 by dt. That is my equation 2. Okay, so in the both equation 1 it is di by dt. In equation 2 also we derived the di by dt. I am equating both the things, so that my objective is to find out the L equivalent. Okay, so I am equating these two, so that in both the cases di2 by dt will get cancelled, so that the total equations which are L2 in the LHS side, L2 plus L1 minus 2M by L1 minus M, the whole thing will becomes in this RHS side 1 by L equivalent into L1 into L2 minus L1 by L2 minus M by L2 minus L1 minus M plus M. Okay, next, if I taking the L1 minus M in the I mean, if I take the LCM over here, so that the numerator will comes as M into L1 minus M. Okay, so in both the cases L1 minus M gets cancelled. If I send L equivalent over here, the total value is L1 into L2 minus M plus M into L1 minus M by this one will comes. So L2 L1 plus L2 minus 2M. That is what I written over here. Okay, so if I multiply with L1 L2 and minus L1 M plus L1 M, M in plus minus sorry, plus into minus minus M into M minus M square. Okay, so that the plus L1 minus M minus L1 minus M L gets cancelled, so that the numerator will comes as L1 L2 minus M square by L1 plus L2 minus 2M. This is the equivalent inductance if the two coils are connected parallelly additive. Okay, so this is for only parallelly additive. Okay, so we have another connection, that is a parallel opposing or as parallel differential. So the next concept is parallel differential, means if the dotted, I mean the current at the dotted terminal in coil 1 and the current has to live in the second coil in the dotted terminal, then we are calling both as a parallel differential. Okay, as we seen in the parallel additive, the current enters in the both the dotted terminals. Okay, in this case opposite, that is a cross connection, so I am representing like this. Okay, so in this case, as I said, the self inductances of coil 1 is minus L1 di1 by dt, and self inductance of coil 2 is minus L2 di2 by dt, and the mutual inductance of coil 1 is M di1 by dt. Mutual inductance of coil 2 is M di2 by dt. Okay, so we know that as per the dot convention, what is be the sign of mutual inductance? For if I write the total induced EMF of coil 1 is minus L1 di1 by dt. So how I am going to write the M if they both are opposing? So the sign what I consider for the self inductance is negative, so I have to write the positive M di2 by dt. That is what I represented. Okay, the total inductance of coil 2 is minus L2 di2 by dt plus M. Why I am considering the plus means, according to the dot convention, we have to consider the, for opposing we have to consider the opposite sign of self inductance, so that I am considering over here. Okay, if you do the same derivation as I shown in the previous, that is series additive, you will get the final as L1 L2 minus M square by L1 plus L2 plus 2M. Okay, in the denominator for a series additive we will get the minus 2M. In the denominator, for a parallel oppositive, okay, we'll get the positive 2m. Okay, hope you understood, guys. Thank you. Be safe. Have a nice day.